Alright, Mr. Kenyonola here, and I'm going to teach you about the Pythagorean Theorem. Okay, so if you didn't watch the previous video on square roots and you think you already know what square root is, square root of 25 is 5, square root of 9 is 3, square root of 1, wait, what? 1, and you think you don't need it, watch it, because if I said the square root of 24, you're probably going to say 12 because it's half, but no. So, square root of 24 is something else, so it's not half. So, watch the previous video, and then once you've mastered square roots, then come back to this video on the Pythagorean Theorem. Alright, so Pythagorean Theorem, it's super important in geometry, honors geometry, in life. So, let's get at it. Pythagorean Theorem. Pythagorean Theorem, discovered by a Greek guy in ancient times named Pythagoras, and he was smart. He was like, hey, this is a breakthrough, so I'm just going to call this the Pythagorean Theorem after myself, so everyone knows my name for centuries to come. Okay, so first thing you need to know about the Pythagorean Theorem, it only works for one type of triangle, one type of triangle, a right triangle. Okay, this could be a scalene right triangle, it could be an isosceles right triangle, but just make sure it has a 90-degree angle, and make sure that you know the parts of a right triangle. The first big part and the biggest part of a right triangle is this side right here. This side is called the hypotenuse. It's the longest side. And how is it the longest side? Because it is opposite the right angle, which is the biggest angle, the widest angle out of all three of these angles. It's the widest, so it makes this side that it's opposite to the longest side. Okay, and these two sides right here, which aren't the hypotenuse, okay, they're just called legs. We have two of them, most of us, and so these two right here are the legs. This one long one is the hypotenuse, and this is called, and for the Pythagorean Theorem, the hypotenuse is represented by one letter, one variable. This is C. Okay, and then these two right here, the legs, are represented by their own variables, A and B. Or it could be B and A. Okay, these two, you could, whichever ones, if you want this to be B, this could be B. If you want this one to be A, yeah, or whatever. But this is the most important one. The hypotenuse has to be C. The longest side. Opposite. How do you know it's the longest side? Because it's opposite the right angle. Okay, so now that we know the parts of a right triangle, we can get to the Pythagorean Theorem. And again, write this down. Only used on right triangles. Okay, so if you've used a right triangle or the Pythagorean Theorem, before, you may recall it's a squared plus b squared equals c squared, but for this video and for my class, we're going to switch the order a little. We're just going to flip it, okay, as c squared is equal to a squared plus b squared. Okay, because the first thing we want to identify is the hypotenuse, and then that's the most important one, hypotenuse. Okay, if we can identify that first, we can get to the rest of them and we could set them up. And these two, of course, are the other two sides called legs. Okay, so Pythagorean Theorem, c squared. So we'll start off with the longest side as the hypotenuse is equal to the two legs squared. So the sum of the two legs, a squared plus b squared. Alright, that's the Pythagorean Theorem. It's used to find the length of a missing side. So let's use the Pythagorean Theorem to find the length of a missing side. So let's actually write this down. used to find the length of a missing side. Okay, not for an angle, but for a side. And let's highlight this. Okay, only use on right triangles. Don't you dare try to use it on obtuse or acute. Okay, right triangles, c squared is equal to a squared plus b squared hypotenuse legs, and used to find the missing side. So highlight all that. All this is super important. Okay, and we're going to be using this a lot in geometry and in life. So let's use it. All right, so here we go. Can we use the Pythagorean theorem on this? Well, it's a right triangle, and we're trying to find a missing side, so I think we can use the Pythagorean theorem. Hey, let's use this color right here. Let's use pink, and let's identify. So let's write c squared is equal to a squared plus b squared. The hypotenuse is equal to the other two legs, the sum of the other two legs squared. So and now let's substitute. Which one is the hypotenuse? The one opposite the right angle. So we can substitute this into c. So x squared is equal to, okay, and a leg squared. You can write 6 squared plus 8 squared. Or if you want to write 8 squared plus 6 squared, that's fine. But this is the most important one. Okay, so make sure you write the hypotenuse correctly. And now let's simplify. X squared is equal to 6 squared is 36 plus 8 squared is 64, and x squared is equal to 36 plus 64 is 100. And what's the opposite? So we're not done because this x isn't by itself. So what is the opposite of squaring something? Yes, hopefully you watched the previous video. Square roots. Okay, and this one is one that we should all know. What's the square root of 100? What are two numbers? Of what pair of itself gives us 100? Yeah, 10 and 10. So our answer is 10. And we know that x equals 10 because, yeah, that's the square root of 100. Also, if you use the triangle inequality theorem, 8 plus 6 is 14. 8 minus 6 is 2. So this number 10 is between 14 and 2. If you don't remember the triangle inequality theorem, watch the previous video on it. Okay? All right, so with the right triangle and the Pythagorean theorem, we can find the actual length, not just the range of values, if we were using the triangle inequality theorem. All right, next example. We have a few examples for this one. Okay, so c squared, hypotenuse squared, is equal to a squared plus b squared. It's a little different, but we know how to do this. Okay, let's identify the hypotenuse. Okay, from the right angle, it's pointing to the 5. A lot of people, a lot of noobs. You're not a noob. Okay, we'll put x. We'll automatically put the variable into the hypotenuse as c, but don't always put the hypotenuse. Okay, 5. Okay, what we're pointing to. That's why we put this first, because we want to identify the hypotenuse first. So 5 squared is equal to 4 squared plus x squared. Leg squared plus the other leg squared. Now let's do some math. 5 squared is 25, is equal to 4 squared. Don't put 8. Don't say 8. This is 4 times 4, which is 16, plus x squared. And now let's get the 16 to the other side. Positive 16 is negative 16, so we're going to subtract 16 from both sides. 25 minus 16 is 9, is equal to x squared. And the opposite of squaring something is square rooting it. Square root of 9 is 3. Yeah, there we go. So x is equal to 3. All right, next example. Okay, we've got 16. We have a right triangle. We have the 16. We have the 8. We have the x. So c squared is equal to a squared plus b squared. Press pause. Oh, my battery just died. So, whatever. You don't need my face for this triangle right here. This is the important part, not my face. Let's substitute some numbers into these variables. So which one is the hypotenuse? Well, here's our right angle pointing at the hypotenuse. So we're going to write 16 squared is equal to 8 squared, one leg, plus the other leg squared. And let's do some math. 16 squared, don't say 32. It's 16 times 16, which is 256. I did that all in my head. And 8 squared is 64 plus x squared. Now let's subtract the 64 from both sides. Now I'm going to grab my calculator because for some reason I don't feel confident about my mental math. So 256 minus 64 is 192. So we've got x squared is equal to 192. Opposite of squaring is square rooting. So, square rooting. Make sure you put your square root in the right spot, not through the x. And we'll square root that. Okay, what are two numbers that multiply to 192? Is it a whole number? I don't know. I don't think we can do that. It's not a whole number. But we can do this because you watched the previous video on square roots. So let's factor tree this and let's find some pairs. So two numbers that multiply to 192. 192 is an even number, so it's divisible by 2. And what's half of 192? Well, 2 goes into 19 9 times, and the remainder is 1. So 2 goes into 12 6 times. So 2 and 96. If you didn't follow my short division, not long division, but short, just use a calculator or ask one of your talking machines like Siri or Alexa or whatever other names that we can't name our children anymore because random machines will talk to you now. Okay, anyways, all right, 2 and 96. Two numbers that multiply to 196 are 2 and 48. And two numbers that multiply to 48 are 2 and 24. Oh man, look at all these numbers. Look at all these 2's. 2 and 24 are, let's switch it up. Let's go 6 and 4. 6 is 2 and 3, and 4 is 2 and 2. All right, and so now let's find some pairs. Let's circle the pairs. We have one pair of 2's. We have another pair of 2's, and our last pair of 2's. So I'm going to write 1, 2 for that first pair, the other 2, and this other 2, and the leftover in our factor tree, and that's a leaf, is this 3, which is in the radical. We put all the leftovers, all the singles in the radical. And I'll simplify this. 2 times 2 times 2 is 8. Radical 3. That is our final answer. If you don't believe me, let's check it. Okay? So, here's my check. 8 radical 3 times 8 radical 3. 8 times 8 is 64 times 3 times 3 is square root of 9. 64 times 3 is, and let's use our calculators for this one. 64 times 3 is 192. So it checks out. 8 radical 3 really is the square roots of 192, the simplified version of 192. So there you go. So x is 8 radical 3. That's the length of this side. Oh, feet. There you go. All right, next example. If this is going too fast, just rewind it and put it on a slower speed. Okay, next one. Right triangle, trying to find a side. So let's use the Pythagorean Theorem. C squared is equal to a squared plus b squared. Let's find our hypotenuse first. There's the right angle pointing to the longest side, which is 15. 15 squared is equal to x squared plus 6 squared. 15 is 225 is equal to x squared plus 36. And let's subtract 36 from both sides. And just so that we're for sure correct, let's use our calculators. 189. So we got x squared is equal to 189. I know I picked some good numbers here. And I don't think a whole number, a pair of a whole number is multiplied by itself is 189. So let's square root both sides. And let's factor tree this. Let's get a factor tree. All right, so not a even number, so not 2, but let's see 3. Let's see if 189 is divisible by 3, and it is. So 3 and 63. How about 63? Is that divisible by 3? Yes. 3 and 21. And 21, is it divisible by 3? Yep. 3 and 7. And let's find some pairs. Are there any pairs? Yeah. Let's circle this 3 right here. So our final answer, and there aren't any other pairs, it's 3 radical 3 times 7. All the singles go inside the radical. Well, we could simplify that. 3 square roots or radical 21. There it is. There's your answer. This side is 3 radical 21. Okay, next one. Second to the last example. Right triangle, trying to find a missing side. So let's use the Pythagorean theorem. Let's identify the hypotenuse, which is x. Okay, x squared is equal to 4 squared plus the square root of 17 squared. All right, so let's simplify. Let's do some algebra. X squared is equal to 4 squared is 16 plus. Okay, so you may know that squares are the opposite of square roots and they cancel out. If you didn't know that, here's why they cancel out. This is really the same thing as square root of 17 times the square root of 17. Yeah? Huh? Okay, because squaring is just multiplying the pair to itself. But when we square root something, what do we look for? Pairs. And we do have a pair. So this would be really 16 plus 17 because the square roots and the square roots of the same pair. Or just remember that squares cancel out square roots, or square roots cancel out squares. So that just disappears and it just becomes 17. Or because of the pair, it just becomes 17. Whichever way. Alright, next thing. Let's just add. What's 16 plus 17? Can't believe I'm using my calculator for this one. 33. But believe it, I just did it. And let's figure out the square roots of 33. Two numbers multiplied to 33 are 3 and 11. We can't factor 3 some more other than 3 in itself because it's a prime number. 11 is a prime number, so it looks like we're done. Our final answer is just radical 33 because 11 times 3 is 33. So there we go. Inches. Don't forget to write the units. Okay, and the very last one for Pythagorean theorem. Hopefully you'll be great at any problem that involves a right triangle and a missing side like this one. Don't be intimidated by this one. Don't be. Okay, so identify our hypotenuse, which is going to be c. So we're going to write radical 55 squared is equal to x squared plus 5 radical 2 squared. And I'm going to put this in a parentheses. Put that in a parentheses. And now let's simplify it. Okay? Remember from the previous problem, a square and a square root cancel each other out. So that's just 55 is equal to x squared plus. And then this means 5 radical 2 times 5 radical 2. Let's multiply. 5 times 5 is 25. Square root of 2 times square root of 2 is square root of 4. And what's the square root of 4? Just 2. Okay? Or, if that was too much for you, you just know that a square cancels out a square root. So we have 2. 5 squared is 25. $25 times 2 is 50. And let's subtract this 50 from both sides. So x squared is equal to 5. But we're not done because the x isn't by itself. We have to get rid of the square. So we're going to square root it. And so x is equal to, there aren't any factors of 5 other than 1 itself. So it's just square root of 5 inches. That is our final answer. So that's the Pythagorean theorem. First thing, it only works on right triangles and when you're trying to find a missing side, not a missing angle. Next thing, first thing you find out is the hypotenuse. That's your C. And then take all the other sides, substitute into Pythagorean theorem, make sure they're all squared. Okay, and then get x by itself. Do some algebra. That's it. So, hopefully that makes your day a lot better and you feel a lot smarter. All right, have a great day.